Hello, myself Dr. D.K.Shedge, Professor in Electronics and Telecommunication Engineering Department, AISSMS Institute of Information Technology, Pune. Today we'll discuss about the Schmitt trigger, inverting Schmitt trigger. Schmitt trigger is actually the improved version of the comparator. Comparator we use operational amplifier in open loop. There, even if output crosses a single level, input crosses a single level, output changes its state. To avoid false triggering in the comparator, that is open loop configuration of operational amplifier, this closed loop comparator, which is nothing but the Schmitt trigger, and here we had chosen inverting Schmitt trigger. That too, this is a symmetrical inverting Schmitt trigger. This is used to avoid the false triggering, and it is formed by applying a positive feedback. And the circuit is called Schmitt trigger, or also it is called as a squaring circuit. So whenever your input voltage is greater than some threshold level, the output voltage then and then only will be changing its state from a previous state. The output can have only two of the states, either minus Vsat or plus Vsat. For example, with this here we'll assume that output is having first of all the state of minus Vsat. Minus Vsat, that's why, sorry, output is having say state of plus Vsat. That's why potential drop across R2 can be given by Vout into R2 divided by R1 plus R2, with Vout equal to plus Vsat. That will be plus Vsat into R2 divided by R1 plus R2, which is also denoted as a VUT, the upper threshold point. So whenever your input voltage becomes greater than, this is nothing but the input voltage applied to inverting input terminal becomes greater than the voltage coming at non-inverting input terminal, the output becomes minus Vsat. So whenever Vn becomes slightly greater than the potential at non-inverting input terminal, the output becomes minus Vsat. The output becomes minus Vsat. It remains minus Vsat. At that time, the potential across R2 now will be given by R2 divided by R1 plus R2 multiplied by minus Vsat. That is also called as VLT, or the lower threshold point. So whenever your input now falls below that VLT, or minus Vsat multiplied by R2 divided by R1 plus R2, the output voltage will change from minus Vsat to plus Vsat. The operation of the circuit can be very well understood from these two waveforms, where we applied Vin as a sine wave, and whenever Vin crosses VUT, the output changes from plus Vsat to minus Vsat. Whenever Vin falls below VLT, output changes from minus Vsat to plus Vsat, and this operation will continue. There won't be any change in the output for change in the input between VLT and VUT. That's why this will avoid the false triggering. False triggering or small excursions coming in the input won't be taken into consideration, or the circuit will not respond to small excursions taking place in the input. The transfer characteristic of this inverting Schmitt trigger, actually transfer characteristics which is plotted output versus input, output voltage versus input voltage. Here we can imagine very well that working of earlier circuit. So whenever your input becomes greater than VUT, the output goes from plus Vsat to minus Vsat, being it's a inverting Schmitt trigger. It will remain minus Vsat until your input falls below VLT. Whenever your input falls below VLT, the output will rise to plus Vsat. It will rise to plus Vsat and it will remain plus Vsat even if your input had fall below VLT. It will change from plus Vsat to minus Vsat whenever your input becomes greater than VUT. And once it becomes greater than VUT input, the output goes minus Vsat. Even if your input becomes greater than VUT by any amount, still output will remain minus Vsat. This kind of curve is also called as hysteresis curve or H curve due to its shape. The graph indicates that output remains in a state indefinitely until the input crosses of any of the threshold level, either VLT or VUT, where VUT will be given by plus Vsat into R2 divided by R1 plus R2, and VLT will be given by minus Vsat into R2 divided by R1 plus R2. As Vsat is same and R2 and R1 are same, that's why the VUT and VLT will have same magnitude. Hence, this is called a symmetrical inverting Schmitt trigger. And the hysteresis factor H, or which is also called as a dead band or a dead zone, is given by VUT minus VLT. If we put the formula for VUT and VLT, we get H equal to twice R2 divided by R1 plus R2 multiplied by Vsat, or it becomes equal to 2 times the threshold voltage. We can have asymmetrical Schmitt trigger also. Asymmetrical Schmitt trigger we can have by introducing only one DC source in series with a resistance of R2, that is of value V. In that case, the output voltage will be given by I multiplied by R1 plus I multiplied by R2 plus V, and I will be given by VO minus V divided by R1 plus R2. Actually, while finding out writing equation for VO, we neglected the input current drawn by the non-inverting input terminal of operational amplifier, which is always very low. So then threshold voltage always will be given by, threshold voltage will nothing but be potential which is getting applied at a non-inverting input terminal, that will be given by I multiplied by R2, that is the drop across R2 plus V. Thus threshold voltage will be R2 divided by R1 plus R2 into VO plus R1 divided by R1 plus R2 into VO. VO can be plus Vsat or VO can be minus Vsat. Whenever VO is plus Vsat, at that time threshold voltage will come out to be positive. Whenever VO is minus Vsat, at that time threshold voltage will come out to be negative. But they will have different magnitudes. Hence, these will be called as asymmetrical Schmitt trigger. Asymmetrical Schmitt trigger. That's why VUT and VLT will not be placed symmetrically along vertical axis. Will have H curve, similar H curve, but will have asymmetrical version of the non-inverting Schmitt trigger. Thank you.